Welcome to CEMEX's series on concrete construction. Today we're going to talk about the key components to successfully building a roller compacted concrete pavement. If you would like to learn more about the benefits of RCC for local streets and roads, please see the other video in this series. Joining us is Corey Zollinger, a paving engineer with CEMEX, who is here to tell us the best techniques to build with RCC for your local pavement, and how CEMEX can help you on your next project.
RCC is the perfect choice for local streets and roads. It has the long-term durability and high-performance characteristics of conventional concrete pavements, with the speed of construction typically associated with other pavement types. When building an RCC pavement, the key components to high-quality construction are mixed design, mixed production, placement, compaction, jointing, and curing. We will cover each of these topics in greater detail in this video. The basic ingredients of RCC are sand, aggregates, cement, and water. A systematic approach needs to be taken during the mix design process to determine each of their quantities to obtain a zero slump mix, as well as to meet the design strength for the project. The aggregates, which typically have a maximum size of 3/4 of an inch, are selected to obtain a dense gradation, avoid segregation, and be easily compacted. A typical cementitious content will range from 450 to 550 pounds per cubic yard. The mixing design process requires experience and knowledge of the local materials. Therefore, we recommend talking to your CEMEX representative to ensure the highest quality mix. Mixing is usually done on or near the work site, and concrete is delivered in dump trucks. The two methods for mixing RCC are either in a pug mill or a central mix plant. The decision is based on project specifications, required production rates, size of the project, availability, economics, and the location. The pug mill plant typically produces 250 to 600 tons per hour and achieves good mixture consistency. It is also portable and can be set up near the job site. The central mix plant typically produces 200 to 300 tons per hour, with the typical mixing time extended to achieve a consistent mixture. Another critical component is to maintain consistent moisture content along the project. Monitoring the moisture content of the aggregate source as well the concrete after placement is strongly encouraged. Too much or too little water makes the RCC difficult to compact, impacting the durability and surface texture. The next step is placement of concrete. The RCC mix is much drier than conventional concrete. Because of this, high-density pavers that are equipped with tamping bars to compact the material as it passes through the screeds are recommended. These pavers are able to achieve greater than 90% of the maximum density directly behind the paver. These pavers can also be equipped with automatic grade control devices to meet the specified smoothness and uniformity criteria. The paver needs to continuously move in order to prevent the formation of bumps and depressions in the final pavement surface. This can be achieved through adequate preparation and planning by the contractor in their mixing, hauling, and paving operations. The concrete is placed and compacted while it is still fresh and workable, usually within 60 minutes of mixing. The RCC pavement is compacted to 98% of the maximum density and is achieved with 4 to 6 passes of a dual drum 10-ton roller in static or vibratory mode. When operating the vibratory roller, it must stay in motion to avoid the formation of bumps. Rubber tire and combination rollers may also be used to achieve a tighter surface texture. Throughout construction, quality control tests assure strength and durability. Nuclear gauge testing is conducted according to the specification to check both the density achieved and the moisture content. Most specifications require an average of 5 tests achieving 98% density, with no test below 96% per lot. If tests indicate acceptable density is not being achieved, cores can be taken to determine the in-place compressive strength to compare against the design strength. Cylinders can also be prepared with vibratory hammers in accordance with ASTM C1435 to check compressive strength. Curb and gutter is installed before paving and serves as a confinement to aid in the compaction of the pavement edge. Tie bars are not used to tie the curb to the RCC. Another method of making the curb is the placement of ribbon curb. Tie bars are drilled and grouted into the finished RCC surface, and conventional concrete is then poured in a ribbon to complete the curb. Manholes are easily installed by lowering the manhole to the elevation of the bottom of the RCC layer. A plywood plate is placed on top of the remaining hole and the RCC is paved over it. Soon after the paver passes over, the RCC is dug out with shovels and the manhole is placed on top of the hole. The RCC material is then placed back and compacted around the manhole using hand compactors and finally the 10-ton roller. Alternatively, the next day RCC can be saw cut full depth around the plate and removed. The manhole is set in place over the hole and conventional concrete is used to fill the remaining void area. As with all concrete paving, proper curing techniques are crucial to help the RCC gain strength, improve surface durability, and eliminate random cracks. Cemex recommends using a high application rate of a white concrete curing compound that should be applied immediately after final compaction to minimize water evaporation. Care should be taken to cover the surface and edges of the pavement. Moisture curing is only recommended in situations where the curing compound is delayed for unexpected reasons. Saw cutting joints on RCC will enhance performance and aesthetics. Before construction begins, a joining plan needs to be developed to identify where the saw cuts and isolation joints are needed. Saw cuts should be spaced at approximately 36 to 48 times the pavement thickness and should extend from all drainage inlets and manholes. We recommend using early entry saws to make the saw cuts to 1 inch deep. Saw cutting should begin immediately after the concrete has hardened enough to permit sawing without raveling, which is typically within a few hours of paving. Adjacent lanes are required to be paved within 1 hour to be considered a fresh joint. When compacting the original lane, the roller remains 2 feet away from the edge. Once the adjacent lane has been paved, the 2 lanes are compacted together at the joint. Cold longitudinal joints are constructed by either placing a shoe on the side of the paver to create a slightly angled edge, or the edge is cut full depth with a saw to create a vertical joint. The adjacent lane is then paved directly next to it, and the cold joint serves as a form to compact against. Transverse cold joints are also formed by cutting full depth with a saw to create a vertical joint. The adjoining slab is then paved directly up against the cold joint. In the end, the appearance and texture is similar to asphalt, only light gray instead of black. The surface texture will depend on aggregate gradation and rolling patterns. The surface can also be diamond ground to achieve quieter performance and smoothness similar to interstate highways. The diamond grinding process grinds less than 1/4 inch off the surface to smooth the roadway and provide increased texture. RCC is the ideal pavement for the urban local road environment, since RCC pavements can be open to traffic within 1 day.
The end result? A paved surface that is durable, economical, environmentally friendly, and ready to use in days.